Actually, Chris is going to start the presentation, so I will let her go first. So Chris, go ahead.
So okay. Hello, everybody. Can you hear me?
Yes, I do. You're good. You're good.
Okay. Hi, I'm Chris Pitocco. Tom and I will be presenting our paper that was published in the Journal of Healthcare Management. It's entitled Using Data Analytics to Improve Hospital Quality Performance. And we are both from Stony Brook University in New York, the College of Business. So the overview is we will discuss our goals, the approach we took to analyze these hospitals, our DEA mathematical model, where we obtained the data, results, the potential improvements that individual hospitals can make, and also we look at overall improvements for the state, and then conclusions and any questions you may have. The objective of the study was, or is, to measure a quality performance. So we constructed a quality performance model for every hospital in New York State using DEA. And I'll explain what special purposes or special purpose hospitals are in an upcoming slide. But what we realize is this is quite complicated. Hospitals are complicated. Patients have different case characteristics. So we took all this into consideration, and what we did was we used hospitals that had fairly similar patients and the type of patients they treated. And the whole goal was to take a look at this and provide a benchmark that hospital managers or hospital administrators could use to specifically improve certain areas of quality in their hospital, or in other words, to deliver better health care. What constitutes a good hospital? So this is very easy, yes, we want patients to be discharged alive. We want that the patient doesn't stay in the hospital longer than necessary, and that the patient is not readmitted within 30 days. So this is a very basic or elementary model, depiction of our model. And so our approach is using DEA, which stands for Data Envelopment Analysis. And for data development analysis, what we're doing is we're measuring what's called relative efficiency. And this is really good for complicated measurements, such as trying to measure hospitals. The other good thing about this is you can use or measure multiple dimensions, and we're looking at performance. And so in each hospital, we're looking at the number of deaths, the average length of stay, and readmission rates. But we also want to look at site characteristics. And so what we're looking at is we're going to provide a performance frontier, and there will be target hospitals that are performing very well. But we realize that there are other things going on in hospitals. So the site characteristics will be discharges, the percent of risk of mortality that is either extreme or major, the expected average length of stay, and we're going to look at patients that are at risk for readmission. And DEA is going to construct what we call a predefined set of hospitals. And these are going to be what's on a performance frontier, or that's what DEA, we measure performance frontier. So these are the target hospitals that are performing very well. What we're doing in our model is we're looking at the number of hospitals. In this case, in New York State, we analyzed 183 hospitals. We looked at the hospitals under analysis, the weights that were placed upon them in the model, and their radial performance. We looked at quality measures. These are what we defined as SIPs, or smaller is preferred. And so if you look on the left side of the quality measures, these are the hospitals under evaluation. We want the deaths compared to the target, in this case, to be less than or equal to the target hospital, the readmissions to be less or equal to the readmissions, and the length of stay to be less or equal to that target hospital. On the right side, the hospital that is on the frontier will have the same number of patients, the same number of patients at risk for readmissions, and they will have either more or equal to the risk of mortality being extreme or major, and they will have more or equal to the average or expected length of stay. The data we obtained is publicly available on the New York State Department of Health. It's called the SPARCS database. In this database, there were 183 hospitals that we could include. So we excluded all the specialty hospitals, and I have on the last bullet, rehab centers, addiction centers, children's hospitals, so that we could get the same case characteristics, or the best case characteristics for our inpatients. In this database, we had 2,233,214 inpatient discharges that we analyzed. So we only used in this model the hospitals that served pretty much general community needs.
So as Chris said, we have 183 hospitals in New York State. And we found that 37 of them have an overall, it's 20%, have an overall performance score of 100%. What that means is that they are on the efficient frontier, or the performance frontier. And we can interpret that by saying that we can't say that they cannot improve, but we can say that we cannot find, it's an absence of evidence that it's possible for them to improve. That means that the model does not find a linear combination or a weighted average of hospitals in the state that can outperform this given hospital in all of the three quality measures that you saw, and yet have the same or worse psych characteristics. So there's no evidence that these 37 hospitals can perform better. But there are 57 other hospitals that are another 31% that have an overall performance score greater than 90%, which is very good. So these are 57 hospitals that are performing well, but they can improve their performance, and we can demonstrate to them, as well as every other facility, how they could possibly improve their performance scores. And we'll see in a little bit that these overall performance scores don't tell the full story. That we have to also look at what we'll call factor performance scores to look specifically at where a hospital can do better. We can see the average performance score was 82%. If we think of this as, we're both professors, and so we think of this as if we were grading students. So the average performance score is a B. The median performance score is about the same, 81%. But there's quite a bit of spread. You can see the standard deviation is rather high, 12.6%. I'll show you a histogram of the performance scores in just a moment. The first quartile of the performance score is 72%. What that tells us is that 25% of the hospitals have a performance score less than 72%. So that's kind of low, 72%. It's a low C, okay, and so it's not very good performance. But the third quartile is 93%, so that means a quarter of the hospitals have a performance score of at least 93%. percent. Next slide, Chris. So here's the histogram, and we see that tall bar over on the right side, and that's where those are the hospitals that are efficient. It actually includes a few others, anybody between 0.98 and 1. So those are the ones that are on the performance frontier or very, very close. And so that's nice. But then once we get away from that frontier, we can see the scores fall off fairly quickly, and there's quite a few basically between 70% and 90%. And you can see the quartiles and the means and so forth. But what's disturbing about this graph is over on the left side is that we have a number of hospitals, not all that many, but a number of hospitals that have very low performance scores. And so from this perspective of the state, it's very important to be able to identify those hospitals and find out what's going on at those hospitals, and then it's up to them, the hospitals, to figure out what they can do to improve their overall performance. And as again, I'll show you in a few moments, we can look at their performance scores and give them very specific guidance as to the areas in which they need to improve. But we see a lot of hospitals here with performance scores in the 60s, also not very good. Okay, next slide, Chris. So these are the, this is a kind of feedback that we can give to individual hospitals. This is kind of like giving them their report cards. And so if we go to facility A, we see it has an overall performance score of 71, which is not that good. That's a low C. And we say, well, that hospital is not doing very well. When we look at factor performances, this tells us where they can improve the most. And so for readmissions and length of stay, it's 71%. So they could improve their performance in those two categories by 29%. But when we look at deaths, we see something rather chilling, and that is that their performance score is only 28%. Suggesting that there's at that particular hospital, they could have avoided 72% of their deaths. And so that's an alarm bell that would go off to tell facility A that they need to do something about their death rate. Facility B looks good. It's got an overall performance rate of score of 91%. And that's pretty much the same across the board. A little bit of a dip on the readmissions, but not anything that's worthy of concern. And so facility B is doing well. We would not be very concerned about facility B, but yes, they can still improve their performance score. Facility C is about average, right? 82% is their overall performance, and that applies to their deaths and readmissions, although they are a little bit lower on the length of stay, and so perhaps that's something that they would want to look at. But also deaths and readmissions, there's plenty of room there for improvement. And then facility D is kind of interesting, because if we just look at the overall performance score, it looks good, 90%. And we see that applies to the average length of stay and almost applies to the readmissions, 87%. But when we look at its death performance, it's only 71%. And so we can see that this is to continue the analogy with students. This is like a student's report card. You know, your kid comes home with a good grades in English and history, but lousy grades in math and science. So that tells you something about where that student needs to focus their energy in order to do better. It's the same idea here. Where do they need to do better? Chris, next up slide. This is what the overall state looks like. So from the state's perspective, how are we doing overall? Well, in the top row, we see the actual data. There were 47,000 deaths in these hospitals and 113,000 readmissions with an average length of stay of 5.2 days. Okay, that's what it was. Now, if every hospital in this data set were to move to the frontier, to move to the performance frontier, what we'd see is that we would have had only 35,000 deaths and about 95,000 readmissions. The average length of stay would have been only roughly 4.1 days. So you can see there's some big gaps there. The gaps are in the third row. We say could have been avoided. We could have avoided perhaps 12,000 deaths and 18,000 readmissions and reduce overall average length of stay by a little over a day statewide. So those are big improvements, and so these improvements are worthy of efforts to try to make them. If we look at the overall factor efficiencies for the state, the average factor efficiency for deaths, as you see, was only 70%. So those couple of hospitals I showed you on the previous slide are not exceptional. They're not unusual to have poor performance in mortality rates. Readmissions and length of stay are about their average, 81%, 82%. But so from the state's perspective, they have an issue with mortality but also generally with readmissions and length of stay. This is not the kind of performance I think that the state would or should be happy with. Okay, next slide, please. So in conclusion, we see most hospitals in the state, that is about 80% of them, can in fact improve the quality of the care that they provide. The flip side of that, of course, is that about 20% of the hospitals can improve the quality. And in fact, as we've seen, we can point to very specific areas for improvement within each hospital. We can say, here's what you need to do. And we can't tell them how to achieve those targets, but we can tell them that it's possible. And how do we know that? Because other hospitals have done it. And so if you can't, then we need to understand why. If every hospital in the state had been on the performance frontier, that's the fantasy land that people who do mathematical models are allowed to go into. We can imagine if every hospital had been on the frontier, we would have had about 12,000 fewer deaths, or about 1 in 4 of the hospital deaths throughout the state would not have happened had everybody been on the frontier. There would have been about 16,500 fewer readmissions. That's a 16.3% reduction. That's quite substantial. The average length of stay would have dropped a little over a day, or over just about 20%. I think that most hospitals would like to see their data look like this going forward. Okay, next slide, Chris. So that is our presentation, and Chris and I will be happy to take any questions that you may have. Thank you.
Thank you.